Hello everyone, good morning. Nice to see such good crowd. Thank you very much for coming. So this is a session on database workflows, basically practical how-tos and demos. It will be light on theory and more on demos and best practices and how you approach a specific use case and how you can go ahead with creating a workflow that mimics a specific use case, which I'm going to discuss about product recommendations. So I'm Prashanth Babu. I've been with Databricks for the past almost 6 years now, and I work as a product specialist data engineering based out of EMEA, London to be very precise. And I've been working on data engineering space for more than 15 years now. So that's a very brief about me. So jumping into the topic, generic statement about the features which you are going to discuss may or may not land into database platform. That's the gist of this entire sentence. And just starting with the workflows introduction, the first and foremost, if you see, this is a pretty loaded statement. Modern data engineering requires modern data orchestration. So there are huge number of formats. There are a huge number of use cases. At the same time, there are multiple personas, for example, just taking few examples like data analyst, data engineer, data scientist, DevOps, and so on and so forth. And at the same time, there are, as I said, multiple data sources or multiple formats. You name CSV, Parquet, Delta, for example, and JSON, and so on and so forth. So there are so many such formats. At the same time, there are so many use cases, and there are multiple triggers. For example, I want a pipeline to run every day at, say, 12 midnight. I'm just giving one example. So there are multiple kinds of triggers, I want my pipeline to run when a file arrives in some specific location, or I want my pipeline to run when a specific table gets updated. It could be an update, it could be a delete, or it could be an insert, anything like that. So there are so many triggers. At the same time, if you see the number of use cases, there is ML, there is data engineering, there is data cleansing, data quality, real-time streaming, and a huge number of use cases. So this has become a big pain for orchestrating pipelines. So this is where, this is from Gartner from September 2022, where they're talking about data pipelines are growing in size, volume, and complexity. So that implies with the same, if you go ahead with the same mindset of what you were doing before, before the data got exploded, it causes us a lot of problems. So that's where we do have some recommendations. In the last 10 years, there's been a huge explosion of multiple orchestrators, namely the most famous one being Airflow. One, it is open source, and two, it's very famous. It's Python friendly, and it's very easy to use. At the same time, there are cloud-specific orchestrators like ADF, which is also depicted here. So these are the orchestrators which are, all of them are being used in the world right now. And out of which, probably ADF and Airflow are the most famous ones, most widely used orchestrators. Now, this is where all these orchestrators could be used to orchestrate all those pipelines, all those tasks, all those jobs which we are showing on the right-hand side of the screen. So this helps for, again, same thing as previous slide, BI, data warehousing, data engineering, and streaming, and also ML and data science. So all these help for orchestrating workloads, for lakehouse workloads. So at the same time, all these external orchestrators create a specific set of challenges. One, it's a bit difficult to use. When I say a bit difficult, if you take an example of Airflow, it requires a bit of learning curve, which would make it a bit less productive. If you learn, after which it is very easy, but still, these tools are not unified with the lakehouse. And if you have a pipeline in Databricks platform, and you are running the pipeline in Databricks, orchestrated by a third-party orchestrator like Airflow, for example, you see the view of a job failing in Airflow, but you need to come to Databricks to see why that error has happened. So basically, there is a mismatch. There is a gap there where if you need to understand a problem or a root cause of a problem, you need to jump between the platforms. So it doesn't give a holistic or integrated view, basically. And also it is a bit complex to manage and maintain. Imagine Airflow 1.0 and 2.0 for a small example. So that's the reason I'm saying here, these tools are not unified with your lakehouse. So this is where Databricks data intelligence platform comes into the picture. Now, if you see the third box at the top, that's orchestration, which is workflows in this specific case. Now, entire thing is Delta Lake and Uniform, on top of which there is Unity Catalog, and then there is a data intelligence engine. Now, all this, like Mosaic AI, DLT, workflow, DLT, DB-SQL, all these could be orchestrated using workflows, which is what I'm trying to say here by showing this also. Like, workflows has a smart scaling algorithm and also a lot of things like retries, triggers, and a whole bunch of features, which we are going to discuss now. And that helps for orchestrating all the workloads in this particular slide. Like, you are working on Delta Live tables, or you are working on plain simple Delta tables using pure Spark, or you're working on something on ML, you're working on something on DB-SQL. All these could be easily orchestrated with Databricks workflows. Now, the main reasons why Databricks workflows is so popular with all our customers is three main reasons. Simple authoring, like it's a simple UI where you can specify the task and you can create a lineage, for example, or you can create a complete DAG as well, just using simple view of front end. That's simple authoring, and also it removes the barrier for any persona like data engineer, data scientist, and anyone who can jump into the platform and start creating the workflows. And at the same time, actionable insights. I will show you how you can quickly see what error, why, and etc. That gives a holistic picture of what exactly is happening in the pipeline and easy to view. And also, you can easily understand why or when a particular task is taking time or a particular job is taking more time than what it is supposed to do. Proven reliability. We have been running some millions and millions of VMs from quite some time now. So essentially, all these workflows have been running, huge number of workflows have been running for quite some time. And this is proven reliability. Like, there is no, one, you're masked out of version changes, like Airflow 1 to Airflow 2, for example. And all those, on top of that, there is proven reliability. Like, you don't need to do anything. And you're not paying anything for Databricks for using workflows. This is a very high-level slide. I'm not going to go too deep into this slide. But essentially, these are the building blocks of a workflow. So you can orchestrate a DLT pipeline, a simple Python file, a simple SQL file, and Scala, notebooks, also jar, and the entire first column is all about various things you can orchestrate as tasks. In fact, you can even orchestrate DLT and also DBT, for a simple example. So those are the various things which you can orchestrate, and there are a lot more also. I'm just showing the main ones here. And then there is control flows. Like, there is a fan-in and fan-out architecture. Like, multiple tasks are going into one single task. At the same time, a single task is bifurcating or probably diverging into multiple tasks as well. And there is conditionals. So I want my pipeline to run, for example, which I'm going to show in next few minutes. I want my pipeline to run only on weekends. I want my task to run only on weekends, so that I can do some machine learning retraining, for example. So that could be achieved using runif. And then there is something called as jobs as a task, where you can specify a job as a task. So that's simple for using for modularity and also easy to maintain and manage as well. And finally, there is new thing called as for each loop. If you're familiar of ADF, it is almost the same, but it has added advantage of having it in Databricks, and you can run multiple versions of the same notebook using for each. And I just briefly discussed a bit about manual triggers as well. So there are multiple triggers which could be set. Manual triggers, file arrival, table triggers, and scheduled, and in fact, even continuous also recently. So these are the various building blocks. Before I jump onto the actual demos and the live demos, I just want to spend a few minutes on serverless workflows, which is in public preview right now. Probably you'll hear more about this in tomorrow's session from Roland. Please take a look at that session as well. Tomorrow at 11:30, if I remember correctly. So serverless compute, as of today, we can do classic compute, which is running VMs and specifying the cluster size and specifying the VM type and a lot of other things. Now that's not anymore required. Like there is an option called serverless compute right now, where it helps for being very simple and fast. There is no config, no knobs at all. So basically, it will help you just jump into the task. You can focus on your task rather than focusing on the optimizing the VM type, optimizing the number of VMs, and a lot of other options which you would want to set. I mean, you usually used to set before for optimizing your pipelines. And this is, again, not all personas working on pipelines would be able to tune and optimize the pipelines. For example, probably machine learning engineers wouldn't be able to configure a pipeline to use optimum number of VMs and configure a lot of other options as well. Like, how does it impact, how does my pipeline impact if it is with Photon or without Photon, for a simple example again. So all those could be easily avoided, and Databricks will take care of that. So I will show you how easy it is. At the same time, it is very efficient. Like previously, when you were working on, say, when you were moving from Spark 2.2 to Spark 3.0, for example, there were a lot of changes which happened between those two versions, and a lot of work has to be done by all the data engineers to make it compatible with Spark 3.0. Now, serverless is versionless, and it is fully managed by Databricks. You wouldn't need to do anything. Like, you just need to select serverless. That's all. You don't need to select DBR type, Photon, number of VMs, VM type, etc. And also, it works on UC, so there is strong governance as well. And reliable. So even if there is a cloud outage, for example, even at that point, we will be able to have the VMs ready because the VMs are coming from the worm pool from Databricks. So that's how it's very, very easy. At the same time, for example, a specific cloud provider had issues in provisioning a specific VM type, for example. At that point, probably Databricks can do a smart failover. Like, instead of using X instance type, we can use Y instance type. So as of now, DB-SQL is in GA. DB-SQL serverless is in GA. We are going to hear more about workflows, notebooks, and DLT tomorrow about the plan, roadmap, etc. So this is basically hands-off auto-optimized compute, completely managed by Databricks. So these are the various things any particular customer would do at their end, like setting up networks, security compliance, and also upgrading the DBRs, which I briefly mentioned before, and also managing efficiency. Like, when I say managing efficiency, someone needs to have SME, needs to be Spark SME to tweak and tune and optimize the pipelines. That is not required now, provided the code is okay. We will be able to do right sizing of instances, and also right instances also could be used. So that's, on top of that, we are going to maintain high utilization, so you are built only for your usage. Now, previously, if you are using 1 to 30, for example, as cluster size, the number of VMs. Now, at any point, probably if you go all the way to 30, maybe not all cores are being used. So that could be avoided with serverless, because we are going to use all the VMs where possible. So that's where I'm trying to say here, like, you don't need to spend time on any of the following, all the four things here. So this is how serverless works, not just workflows, but SQL also works the same way. Like, there is a worm pool on the extreme right there. There is a worm pool from which Databricks will have provisioned a number of ready instances, and all those instances are available. And as and when customers start using, depending on the patterns, we'll try to do some prediction and pre-provision some VMs so that customers do not see the lag or latency when Azure or AWS or GCP are giving the VMs. So that helps for the instances to be ready at any point so that it will be available for the customers to quickly use them. So probably the most impactful slide in this section is this. Like, previously, there are some DBUs, and then there is operational cost, and then there is infrastructure cost. So you were getting two bills, one from Databricks and the other from cloud provider. Now, it's all into one single bill, which is marked as DBUs, and rest all will be TCO savings. So basically, there is a lot of TCO savings there because you're moving to serverless, and as we discussed in the previous slides, no management of DBRs, no need of ensuring high utilization, et cetera, et cetera. So this is how the UI looks for serverless workflows. I will show in detail in the next few minutes, but there is, if you see the slide here, so there is compute, and we only select serverless. You don't need to select the DBR type, Photon, and a lot of other things as well. It's fully managed and reliable, and less than 60 seconds is the startup time for serverless workflows. And we discussed a bit about versionless with auto updates, and there are system tables available, and automatic instance type failure as well is available. And also there are a couple of more features coming soon, like cost optimized. If you're aware of DLT, there is a dev mode and production mode. We are going to take the same way here as well for when we are going to have development mode for workflows as well. And finally, there is budgets for cost control, cost observability, and a whole lot of things as well. Probably one of my last slides here. So this is how the serverless workflows and notebooks works. Like, there is a REPL VM which tries to connect to Spark Connect, and from Spark Connect we do try to get to the driver. So whatever you're doing, it's all a full user code isolation, both on the client and driver and executor. So anything you're doing, like there is Spark driver, and then there is isolation, driver isolation, then there is Spark executors, again, executor isolation also is there. So what you code is happening in the REPL VM that gets executed through Spark Connect to the driver and finally to the executors. That's the entire architecture, and that works exactly the same way in both notebooks as well as workflows. Now, I'm moving to demos, which I mentioned before. So this is my pipeline. I mentioned a few times before about this pipeline. So I will just show you what I'm trying to do here. It's a big pipeline. I will just briefly explain what exactly I'm trying to do here, if it's visible, yeah. So this is a huge pipeline where I'm trying to do some kind of machine learning as well as some BI dashboarding as well as a lot of transformation and other things. So this pipeline is more for product recommendations for a retail CPG customer, just to be very precise here. And we have some dimension data in stores, customers, and products tables. And then there is fact table information in transactions. So what we are trying to do is we are trying to get some insights from these tables and going all the way from bronze, silver, gold, and then doing some BI dashboarding, and finally doing some machine learning bits as well. And there are some some smart things which we are trying to do here. Let me walk you through some things. Like, this is the first thing. Probably I will just go back and show how easy it is to create a simple job. So just click on create job. This is where you land. So I will just do for a simple, if you're not aware, probably this might be helpful, how to create the job and what all features are available in Databricks jobs. So, so this is the Databricks Workflows job page. Now you see a lot of details here. And the first thing I would like to do is say load. I'm just giving some name, load as the task name. And I can do, there are multiple task types which are accepted, like there is notebook, there is Python wheel, Python script, SQL, and a lot of other things, including there is something called new thing called as for each, and there is if-else condition, and so on and so forth. So there are a lot of things available, including DLT. And DBT also, you can orchestrate DBT also. So for this particular simple demo, I'm just going to do only notebook. And then let me take one of the notebooks. Anything should be okay. Yeah, let me take that. So I just took one simple notebook. I'm not going to run it, but I'm just showing it. So this is where I was talking about previously you were supposed to select a lot of things. Now that's all masked out. There is a simple serverless option here. Now, if it was not serverless, if you are going to go towards classic, then you would need to do, you need to select a lot of things. For example, I'm just showing you this. So these are the various things which you were supposed to select previously, right from DBR type to number of VMs as in instance types, worker node type as well as driver node type, and you need to select auto scaling and a lot of things as well. So and also photon. So many things you would need to select. Now that's all masked out for you. So you don't need to do anything. You just need to select serverless. That's all you need to do. And then moving ahead, there are multiple other parameters like in serverless, there is no concept of dependent libraries. Dependent libraries will come from environment. So that's the reason it is masked out. So there is a new concept called environments, which you can read about it in the docs. I will just showcase one simple thing here. Now, either you can use environments or you can also use pip install in each of the notebooks, so to use the libraries. And we can, if you are not aware, we can pass task parameters, you can pass job parameters, and we can, so that you can automate the pipeline flow. There are notifications which you can specify for, it can be done on individual tasks as well as it can be done on the complete job as well. I will show on the job, but for now I'll just skip that. So there is retrace as well. So if a pipeline fails, we can ensure that it retraces n number of times. That could be set within this itself. And then there is thresholds. Like for example, I want my pipeline, my pipeline usually completes in say 20 minutes, but I don't want my pipeline to keep running for a long time, like say 30 minutes. I don't want that to happen. So for those reasons, this we are setting it on the individual task, but essentially we can do that on the complete job as well. So I can specify warning threshold where I get a warning email, either an email or even for that matter, it could be a Slack message or PagerDuty or Teams message. Any of these could be set. So for example, I don't want my pipeline to run more than 25 minutes. At that point, I should get a warning. At the same time, I want my pipeline to crash if it is running more than 45 minutes. I'm just giving one example. So this ensures, one, costs are in control. Two, you understand upfront, like there is something happening, I need to take care of it. And all those notifications could be sent to any of those which I just mentioned. So I'll save this. And I can add notifications, say my email address, for example. So at the same time, okay. I will get a message whenever this job starts, and at the same time I can skip if it is a cancel run or if it is any of those options there. So this is how I can do this. So all this is set on the individual task, but we can do this on the complete job as well. And there are a lot more things like there are job details, and you can even add tasks. You can even add tasks, add tags where you can specify, like say for example demo dice. I'm going to specify it as dice here, and this way you could. I mean, this is helpful if you want to filter out the jobs in the first page, in the workflows page. And similarly, a lot of things like you can get the code from Git. That's also possible. And yeah, there is a bit of information here which I would like to discuss. There are multiple trigger types: scheduled, file level, delta table update, and continuous. So for example, I'll just take scheduled for now. There is simple and advanced. In advanced, you can specify an advanced type of schedule. At the same time, if you have even more advanced, probably you can use the cron syntax, and Databricks follows Quartz cron syntax. If I want to move to, say, a file level trigger, whenever a file lands into one specific place, one specific bucket, which is under UC, this pipeline should start. So we can do that as well. And similarly, there is delta table. I can specify some table name here. Whenever the table gets updated, this particular pipeline immediately triggers. And then there is continuous also. So for now, I will skip this. So there are job parameters which you can pass so that you can automate, like every day, for example, So taking a simple example, depending on the date, I want my pipeline to look at that specific bucket and load the data. So all that could be done through job parameters. You can pass multiple job parameters to this pipeline, and they can run them anytime. And then there is queuing. Queuing is very useful if you have hundreds and thousands of jobs running at the same time. So you can't, probably your cloud provider will not be able to provide all the VMs at that same point of time. So that's where queuing helps. Queuing can retain the workflow for up to 48 hours, and then within that time, it can run the pipeline. So these are, at a very high level, these are some of things. And finally, I just want to show this as well, where you can see the entire thing as code. So this is completely as code, where I can see all the things which I've just briefly mentioned just now. Everything you can see it as code, not just on the UI DAG. So this is about entire DAG. Now coming back to my use case on product recommendations. So going back again. So as I mentioned, I have data in 3 tables: customers, products, and stores. These are the 3 dimension tables, and then there is a fact table called transactions. Now I want to utilize these 4 tables, and I want to run my pipeline depending on whatever is the frequency, and create proper bronze, silver, gold medallion architecture tables, architecture data, and then do some kind of machine learning as well as BI dashboarding and do some alerts. Like, for example, in one specific area, all of a sudden a particular product got very famous. Why and what insights would that cause to the data analyst, and how can they remedy, or how can they add more inventory to that particular store, for example. All these things could easily be done from within Databricks with the BI dashboard as well as Databricks workflows. So just going ahead, at the same time, there are a couple of things like, if at least one of my tasks fails, like this is the entire pipeline. Now, when I'm done with my machine learning, or even otherwise, without even machine learning, if any of the previous tasks failed, we have an option where you can specify, if at least one of the tasks failed, I want my pipeline to do something else. So these are the various options which you have, like run if dependencies, where you can specify if all succeed. By default, everything is all succeeded. But if you want to do, even if at least one of the upstream tasks failed, I want to say a specific task to run. So in this case, I'm doing cleanup and log. So that's what is happening here. But essentially, this is where we are cleverly doing a couple of things. Like, one other thing is, if it is a Sunday, I don't want to publish my model stats. I rather want to retrain my model based on the data which is there. So even that could be easily achieved. Like, there is an if-else condition, like you can see here. I named my task as is Sunday, and it's an if-else condition. The task type is if-else condition, and I can specify job.start time and ISO weekday. This is the parameters which you can pass to the condition. And if it is 7, like Sunday is 7, and at that point, this will, instead of running, if it is normal weekday, it would have been doing publishing model stats, but on that specific weekend, like Sunday, it will rather do retraining the model. So this is where the interesting bits are happening there. There are a couple of other things, like, as I mentioned, there is a SQL BI dashboard which I am refreshing, and also updating a couple of things, and also alerting as well. All that is happening in the BI dashboard. And in between, I'm also orchestrating a complete big DLT pipeline, which is doing aggregations, computations, and also expectations, trying to ensure everything is working fine. So if this is how you can easily define a complete workflow, right from ingestion to transformation, and then there is some machine learning, and then the BI, and you name it, anything and everything could be done. Either it could be a DLT pipeline, it could be a DBT pipeline, or it could be anything for that matter. All that could be easily orchestrated within workflows. At the same time, this pipeline, one more cool thing I didn't show till now is schedule trigger. So you see, my trigger is based on table update, and I have a specific table named marketing analysis prod records. So whenever this table gets updated, at any time, immediately, like within few seconds, this particular workflow will get executed. I'll show that bit as well how I'm triggering this. So this is how you do it with table triggers. At the same time, there are multiple other options like scheduled and file arrival and other things as well. The beauty here is I have orchestrated this pipeline with job notifications, which could be start, success, failure, as well as duration warning, which I briefly mentioned in the previous discussion. And I'm also sending the messages to a Slack channel as well, where a specific team can take a look at them. And if I can go to my mailbox, I can show you what's happening there as well. This is my duration metrics. I want my pipeline to send a warning after 15 minutes, and it should basically time out after 30 minutes. And rest all are exactly the same. So if I go to my Gmail and quickly jump to job alerts, so this is what I was showing. Like I think I'm doing it yeah, I need to show that. So one last thing is how I am simulating the data. So there is a specific pipeline which I am triggering every 30 minutes. So starting at 2 past the hour, so it's some more time left. But essentially, you can see I'm running every half an hour at 2 past. So last time ran at 10:32 a.m. It will run at 11:02 a.m. next. So whenever this table gets, I'm doing a simple ingestion where I am updating a specific table, the table which we saw in the previous notebook. And so this is the same table which I was showing, main.marketinganalysis.prod records. Whenever this table gets updated, then and there itself, our table gets updated. Our workflow will start trigger, basically. And that is also shown here. So you see here, there is launched by, table launch, et cetera, et cetera. All that information you can see here. At one time, I did manually, even that you can see here. So the way you are triggering also is visible. This is what I was saying, the observability and how you can easily flip past. Like, so for example, I was trying to do something today, and then I managed to crash my pipeline by simply adding this statement here. Like, I'm doing some coding, and by mistake, I left a semicolon, for example, a syntax error, basically. Now, if you see, what I'm trying to showcase now is more to show I'm doing a run now. So it is going to trigger manually. You can see already here it is showing manually. The trigger type is manual. It already started. So this is when I would get, yeah, you can see here. This is manually. This is my Slack channel where I'm pushing all my notifications through webhooks. So my tasks, whenever my workflow started, then and there itself, I do get when it launched and what is happening and all those messages. Previously, it was triggered through table update trigger, so that came fine. So all this is right happening in front of you, and the entire demo is happening right in front of you. So this is where I was showing all this, and let me go back to my page. One thing I wanted to show here is how we can repair a job easily. So that's something which I wanted to show. Let me cancel one of the jobs so that I can show that. I induced an error, if you remember here. I induced an error. So at this point, I can quickly cancel, run, canceling. Okay, let it cancel. Yeah, it got canceled. Yeah, both of them got canceled. Now I'm going to do manual run, just to show that my error, my pipeline will fail. At the same time, I can go and modify the code and immediately do a repair. So this is what I'm trying to achieve here. It might take a bit of a minute or two. So in the meantime, I'll just jump to my deck. We have just 5 more minutes, so I want to run through some best practices, and then we'll go back to my my demo. So these are some of the best practices which I've been collating. and it might be very useful to you as well. When you're doing anything on prod, we'll take questions after you. Whenever you are doing development, automated clusters, interactive/all-purpose clusters should be used. Whenever you move a pipeline to prod, at that time, ensure you always use automated or job clusters. One, they are cheaper, and two, it's always better to have them running in an isolated environment so that no other pipeline is taking the resources and everything else. We briefly discussed about serverless workflows. You saw how fast the VMs have come up in the previous example as well. It is fully managed, fast clusters, et cetera, et cetera. We just discussed. You saw multitask jobs. We had a huge pipeline where we were running ingestion to transformation to BI to machine learning, everything in a single job. And that's because of multitask jobs. Always prefer to use multitask jobs so that you can bin pack multiple number of tasks into a single job, and that also helps to you do cluster reuse as well. So this helps in multiple ways. One, whenever we are getting a VM from the cloud provider, there might be some lag. If you do multitask jobs, you can potentially reuse the clusters wherever the requirements are meeting. And always use the latest Databricks runtime LTS preferably, so that all the new improvements and everything seamlessly blend into the new VMs. And enable Photon for all your pipelines. And maybe you're already aware, Databricks native vectorized query engine is Photon. Cluster reuse, I briefly mentioned in the previous slide, but yes, cluster reuse. Please utilize cluster reuse if you are using classic jobs, classic workflows. Repair and rerun, I will be showing that in a minute. So, but still, it is going to be really helpful to do repair and utilize the feature of repair and rerun so that you can save money and time. And also, no pipeline, you can ensure the pipeline is idempotent and take care of itself. Late jobs, we discussed about webhooks and duration warnings and timeout warnings as well. There are multiple types of triggers, most recently file level triggers and delta table triggers. Most of the time, most of our customers use individual data engineers as their owner of a pipeline. But what happens if the data engineer leaves? That workflow will stay in a limbo. So instead of that, we suggest to use run as SP service principal. So ensure all your pipelines are owned by a service principal and not by any data engineer. We didn't cover a bit like reuse jobs. Please check my last summit talk where I'm talking about reusing your jobs as well. That essentially helps for maintaining a number of tasks into breaking down into multiple jobs, and at the same time ensures easier testing and more so integration with multiple teams as well. DB-SQL and DBT, DLT all could be orchestrated. You always use cluster tags for cost attribution and chargeback across the teams. Enable notifications, Slack, webhooks, Teams, PagerDuty, emails, everything is possible. Control flow, we saw runif and if else. And parameterization, unfortunately, I do not have time, but I can talk to you in detail after the talk as well. There are multiple ways you can do it through job parameters, dynamic values, and task values. There are some limits which are applicable for each of the workspaces. So ensure you stagger the pipelines so that you're not hitting the one cloud provider VM issues and also cloud provider IP address limits, etc. If even then it's a problem, please look at serverless workflows. And queuing, we discussed about 48 hours. There is a new thing called as DABs. Please take a look at DABs. Databricks asset bundles, that is very useful for CI/CD. And we discussed about for each. So these are some of the things, and I'll quickly jump to my demo. But these are some of the references. I'll leave them in the slides. Probably take a look at them. And there are other sessions as well. There are 3 more sessions on workflows. In fact, mine is also repeated on Thursday, but these are the 3 sessions which are happening tomorrow and day after tomorrow. So I'll just jump to my demo. You can see this. My pipeline failed, and you can also see why it failed. It says task silver dim customers failed with message, workload failed. So at a snippet view, I can see why or how a particular pipeline failed. Now I can go into the job. This is the graph. It might be too small. Let me zoom in. Yeah. So this is the view where you can see which of my tasks have failed and which of my tasks have successfully run. So silver dim customers failed. Because of that, the entire downstream pipelines, downstream task did not go forward. But this task, which is run if at least one failed, that's what is getting triggered there. Now we can also view a complete timeline, and here is where you can see what is happening and why it is happening and etc. So I have my pipeline, as you remember, I explicitly added a semicolon here, which is a syntax error, and that's the reason it failed. Now if I go back to my run and do a repair run, so you can see here, Databricks is telling me, is giving me an option what all tasks I want to rerun. So I can specifically choose which tasks I want to run, or I can even in fact remove them. So these are the number of, now because our silver dim customers failed, entire downstream failed, so now skipped rather, now I'm going to do repair run. So this will trigger automatically the entire downstream of silver dim customers, and it will not do anything else other than, the tasks which were successful wouldn't be touched. Like if you see here, this is where my job rerun started. It started from silver dim customers, and it didn't do anything with bronze fact transactions and the for each task which we had earlier. So this is how the powerful the repair and rerun task is, and it helps you to easily understand and see what is happening and why it is happening and other things. And if you see, when my job is running, this is the status, and it shows how each of the tasks, like it is also showing this is the second attempt when it's running. My attempt, it will fail again because by mistake, I missed out to remove the semicolon. Yeah, it will fail, but yeah. So that's what it is. Yeah. So that's my demo, and also probably I will show one last time my screen. Yeah, my run failed. The error message which I got directly to my Slack, it would have reached my email also. So this is how it is so seamless and useful to do everything within one platform, which is Databricks Workflows. And also, it helps you to use all the various features of workflows within this. So if I go and let me, yeah, same error. So it should pick it up once it is able to. Yeah. Now it should run fine. Yeah. So I basically took 3 minutes more than 40 minutes, scheduled 40 minutes. But yeah, this is how you can do most of the things. You can refer to my previous summit talk as well, where I did talk about some 7 features. And if you have any more questions, yeah, sure. Please, you can talk to me separately, or we can talk now also. Yeah.